This will be for the Khan Academy exercise, linear versus exponential growth from data. All right, so we've been over the exponential equation plenty of times, y equals a times b to the power of x. Now, we also have to deal with the linear equation, y equals mx plus b. Now, in their answers, their linear equation will be in the form of y equals b plus mx. So they just reversed the mx plus b and made it b plus mx. You'll see that in their answers. And for the linear equation, b is the initial value, and m is going to be the slope. Okay, recall the slope equation, y2 minus y1 divided by x2 minus x1. Also, recall that if you add or subtract the same number each time, that's a linear equation. If you multiply or divide the same number each time, that's an exponential equation. All right, the number of views on a cat and dog video after they're uploaded are represented by the following tables. So here's the one for the cats, and here's the one for the dogs. Determine whether it is best modeled by a linear or exponential. Okay, so for each one, the cat and dog video, we have to indicate if it's linear or exponential. The easiest way to do it is to test if it's linear first, and if not, then you know it's exponential. So let's go to the cat video first. All right, let's test it, see if it's linear. How far do we go from 50 to 313? Okay, if we do 313 minus 50, that is going to be 263. Okay, to get from here to here, that's plus 263. And if we go 1950 minus 313, all right, that's going to be well over 1,000. Okay, that's going to be 1,227 or 37. Either way, though, it's not even close. Okay, this adds 1,237. Okay, we are definitely not adding the same amount each time. So for the cat video, that's going to have to be exponential. You can double check and do 313 divided by 50, 1950 divided by 313. But if it's not linear, it has to be exponential. All right, moving on to the dog video. From here to here, if we did 452 minus 10, that, of course, is 442. Okay, so we're adding 442. And let's see, if we add 442 again, 452 plus 442, 2 plus 2 is 4, 5 plus 4 is 9, and 4 plus 4 is 8. 894, close, pretty close. Okay, so we didn't add 442. We actually added 437. But if it's close enough, it's close enough. Let's test one more. 1330 minus 889. $13.30 minus $8.89. All right, I get $4.41. So this is plus $4.41. All right, if it's close enough like it is here, then you can say it's linear. All right, close enough. So the dog one is linear and the cat one is exponential. All right, the cost of buying a small piece of land since 1990 is represented by this table here. Which models for C of T, the cost of a piece of land T years since 1990 best fits the data? Okay, so notice the ones like answer A and answer D, they are in the form of A times B to the X. Okay, that's exponential. And the ones like, I'll do it in a different color. The ones like answer B and answer C, they are in the form of y equals mx plus b, or like I said, it's actually reversed, b plus mx, okay, and that is linear. So what you want to do is first determine if it's exponential or linear. Eliminate 2 out of 4 answers and then work from there. Okay, so let's do that first. Now, if you look at these numbers here, if we go from here to here, 36.9 minus 30, that's just 6.9. Okay, so that's plus 6.9. Now, if we did 44.1 minus 36.9, all right, I'll make this 11 and I'll make this 3. 11 minus 9 is 2. 43 minus 36 is 7. That's a 7.2. Looks linear to me. Let's be absolutely certain. 51.1 minus 44.1, that's plus 7. Okay, close enough. So we can see that this is definitely linear. All right. So it's in the form of y equals mx plus b. Like I said, they reversed it and made it y equals b plus mx. So what is the initial value for b? Well, that's at x equals 0. Okay, make sure this is a 0 and the b value is 30. So it's going to be y equals 30 plus mx. If we have two answers with 30, then we just have to find the slope, m. Okay, so let's look at the linear answers that are in this form right here, y equals 30 plus mx. All right, so we can clearly see answer B is a possibility and answer C is a possibility. Those are the linear ones, and they both start with a 30. This is exponential. It's not A. This is exponential. It's not D. So it's one of these two. We have to find out if the slope is going to be a 7 or a 3.5. So let's take a look. Now, the good thing is for the slope, you can actually estimate. All right, so we said with slope was y2 minus y1 over x2 minus x1. Okay, so we'll call this y2 and y1. We'll call this x2 and x1. All right, y2 minus y1 is going to be 36.9 minus 30. All right, 36.9 minus 30. And x2 minus x1 is just going to be 2 minus 0. All right, you could really estimate. Instead of 36.9, you could round off and make it 37. 37 minus 30 is 7. 2 minus 0 is 2. And that equals 3.5. All right, I know that was one of the answers. Alternatively, without even going through all that, earlier, we said from here to here, this was plus 7. And we can see from here to here on the x's, 4 to 6, that's plus 2. So the change in y is 7, and the change in x is 2, okay? And 7 divided by 2 is 3.5. So I really didn't have to do all of this. I just could have taken the 7 that I already had before and divided it by 2. All right, so that is clearly this one right here because of the slope of 3.5. Answer C. All right, so these are easy. Like I said, for each one, you just choose if it's linear or exponential. Okay, we basically did these types of problems already. So for each one, first test if it's linear. If it's not linear, if you're not adding or subtracting the same number each time, it's going to be exponential. All right, so those are easy. All right, last one. Number of branches after the year 2000 is represented by this table here. Which of the following, which model best fits the data? Okay, once again, some of these are linear, like A and D, and some of these are exponential. So you want to determine which is which first. All right, test to see if it's linear. If we go from 16 to 23, that's plus 7. If we go from 23 to 33, that's plus 10. 33 to 48, that's plus 15. Okay, clearly we're not adding the same number each time. It is not linear. So this is going to be exponential. All right, exponential is in the form of y equals a times b to the power of x. We know a is the initial value at time 0. So that is going to be 16. All right, so y equals 16, sub in 16, times b to the x. Now we have to solve for b. All right, so let's see here. We already used this point. We already used this point to get 16. Now we have to choose another point, okay? This column is your x, and this column is your y. So let's choose the one below it, 2 comma 23. All right, the 2 is going to be your x coordinate, and the 23 is going to be your y coordinate. So let's sub it in here. All right, if y equals 23, that's going to equal 16 times b, and x is 2. So that's going to be times b squared. All right, solving for b squared, the opposite of times 16 is divided by 16. So the 16s cancel. B squared is this right here. The opposite of squaring something, the way to undo something squared, is to take the square root. So you want to take the square root of both sides. Okay, square root of b squared is just b, and I'm going to do the square root of 23 divided by 16 on the calculator. All right, square root 23 divided by 16. Close parentheses right there, hit equals, and it looks like we're going to have to round off. Okay, I'm going to do one decimal, so if the second decimal is 5 or more, you round it up. So 1.1 is going to become 1.2. Okay, and that is going to be your value for B. All right, we said A was 16, and we said B was 1.2. 16 times 1.2 to the x or to the t, same thing right there. Just real quick, let's say for the sake of the argument, these did not go up by 2, but let's say they went up by 3, and we were trying to do the equation a times b to the x. All right, and we already said that a was 16 at the value of 0, and that's going to be times b. So let's say these went up by 3, and this was the xy coordinate. All right, let's say the 3 was your x, and the 23 was your y. Well, you would sub in 3 in place of x right here. It'd be b to the third, okay? And the y value would be 23. So in place of y, I would just put a 23. Let's say you had to solve for b to the third. I want to make sure people know how to do it. The opposite of times 16 is divided by 16. The 16s would cancel. And now instead of taking the square root, what you would do is take the third root of both sides, okay? Because this is to the third power. You would take the third root of 23 to the 16. All right, the third root of b to the third is just b. And we learned this already. Third root and this would automatically be to the first power. We can convert that to a fractional exponent. The third root of 23 over 16 would be the same as 23 over 16 to the power of 1/3. Okay, remember the exponent here is in the numerator and the root is in the denominator. So instead of square root, it would be third root, or 23 over 16 to the 1/3. All right, so that would be 23 divided by 16. Use parentheses, 23 over 16 to the power of 1/3, or 1 divided by 3. Close parentheses, 23 over 16 to the power of 1/3, and hit equals. And you would round that off. Okay, so just remember, if it's third root, let's say the third root of x, that's going to be x to the 1/3. Okay, if it were like the fourth root of x, that would just be x to the 1/4, and so on. Okay, so you could transfer the root into an exponent, and then it will be easier to use it, do that on the calculator.